I hope you're ready because this is the last lesson for this unit. We are going to make it hopefully a quick one, talking about intermediate value theorem, which is regularly abbreviated as IVT, so you do not have to write it out. That is acceptable on the AP exam there. So we're going to use the intermediate value theorem to make conclusions about functions. What this says is, roughly speaking, if you have a continuous function, you can't skip values. Okay, so if I have a continuous function here, I have to reach a value between 5,000 and 10,000 because my function at this point is 5,000 and at this point is 10,000. So we have to hit every value in between 5,000 and 10,000. This is not continuous, therefore IVT does not apply. Okay, so you do have to say that it's continuous, and then you can use the IVT. Okay, so prove that the equation sine of x equals 0.3 has at least one solution. Let's grab a pen here. We are going to say we can apply IVT because sine of x is continuous, since we know that the sine of 0 equals 0, okay, and the sine of pi over 2 equals 1, so thinking of our unit circle, here's our 0, here's our 1, that somewhere on the interval from 0 to pi over 2, and I'm not going to include those values because I know that doesn't work at 0. So on the interval between 0 and pi over 2, sine of x must equal 0.3 at least one time. Okay, and it's pretty simple there. I'm gonna go there. There's a corollary that talks about the existence of zeros. So if the function is continuous on a to b and f of a and f of b are non-zero and have opposite signs, so one's positive, one's negative, then we have to have a zero on that interval. We're going to use something called the bisection method to do this. And you're going to use the graphing calculator, so I'm going to go ahead and pause and pull that up so it's ready without wasting time. Okay, so what I'm going to do is I'm going to use my calculator, I'm going to plug 0 into the function, and then I'm going to plug 2 into the function. And I did that here. Ignore this middle line, I forgot to divide by 4, so I got 1/2. When I plug in 0, I get 1. When I plug in 2, I get negative 0.786 if I round. So I'm going to go ahead and write those down. F of 0 is 1, which is greater than 0. And f of 2 is negative 0.786, which is less than 0. So what we're going to do with that is we are going to guarantee, well, this guarantees that we have a 0. We're going to break these intervals in half to see what happens here. So from 0 to 1, and we're going to test those endpoints, and then from 1 to 2, and test those endpoints, and see what happens. So f of 0 is positive, f of 2 is negative. I'm going to go ahead and plug in 1 and see what happens. So I'm going to go back to my calculator. I'm going to hit second and then enter. And then I can change these, because I'm plugging 1 to 1/4. Oops. And 1 without retyping everything. So at 1, we have a negative. I'm going to flip back here. And I'm going to scroll down a little bit and extend my page. So that means that f of 1 was negative and f of 1 was negative. Because these are both negative, we can't guarantee there's a 0 here, but because one's positive, one's negative, we're going to split this in half again. So we're going to go from 0 to 1/2, and then from 1/2 to 1. So we know that this is positive and this is negative. I'm going to go back and plug in 1/2 now. So second entry, we're going to plug in 1/2, which makes this 1/8. And this makes this 1/2. So I'm going to make this point and insert a 5, so 1/2, hit enter again. So now that's positive. Let's go back here. When I plug this in, this was positive and this was positive. Therefore, we need to split this one in half. So we're going to go from 1/2 to 3/4, and from 3/4 to 1, so negative positive. Let's plug in 3/4. Okay, so go back to my calculator, entry, plugging in 3/4, which would give us 3/4 would be 3/8. No, 3/16. And then this would be 0.75, so I'm going to insert a 1 or 0.7. And then we're going to hit enter. And we get a positive there. So my 0 has to be between those two values. So we're going to test one more time. And we're going to do from 3/4 and to 1. Sorry, 3/4, and I'm going to go to 7/8 because this is really 6/8. So 7/8 and then 7/8 to 1. So we know negative, positive. Let's plug in 7/8. We're going to do second entry. This will be 7 over 8 times 4 is 32. And I'm going to make this just 7/8. And hit enter. And I get a negative there. So we've kind of narrowed this down, that this is our interval. So that somewhere between 3/4 and 7/8 we have a 0. So the 0 lies on the interval from 3/4 to 7/8. I'm actually not going to include those because I know that this is a positive and that's a negative, it's not 0. So pretty much the way we would write that in calc speak, f of x has a 0 at c when c is between 3/4 and 7/8. And again, I'm not including those endpoints. Okay, that's it for today. That's it for the unit. Let's keep practicing. Have a great day.